All right, today we're going to be talking about absolute value equations. And before we get into absolute value equations, let's just investigate why the process of solving absolute value equations is the process it is. So if we consider the absolute value of x equals 3, well then we know that x can be 3 or negative 3 because the absolute value of 3 is 3. The absolute value of negative 3 is also 3. So that means the solution to this is the absolute value, whatever is in the absolute value between the absolute value bars, that can be 3 or that x can be negative 3. So to solve these, we take whatever is between the absolute value bars and we set it equal to the positive and negative of that. That's the reason that works. So let's say we wanted to consider solving the absolute value of x plus 3. Is equal to 2. Well, as we just talked about, whatever is between the absolute values when your absolute value is equal to a number, whatever is between the absolute value bars, x plus 3, this can be 2, or x plus 3 can be negative 2, because if this is 2, the absolute value of 2 is 2, and if this is negative 2, the absolute value of negative 2 is also 2. So we solve this very simply by subtracting, and we get negative 1. Here we end up with negative 5. So the solution to that is negative 1 and 5. Now, kind of a nice way to connect this to a graph is if I graph the absolute y equals the absolute value of x plus 3, while we know the graph of this shifts the absolute value of x to the left 3 places, and we get this v that looks something kind of like this. Now, if I set y equal to the absolute value of x plus 3, then we want to know when y is 2. Y equals 2 is the vertical line at 2, and when I graph this vertical line, we see the vertical line crosses at x equals negative 1 and at x equals negative 5. And that gives us kind of a visual, more of an intuitive feeling of what it means, why the solution is what it is, and how it connects to the graph.